Hey guys, Laura Whitmer here, founder of STP. Welcome to the official August SAT predictions video. For those of you who don't know me, I'm an SAT prep coach with 18 years experience. I've helped hundreds of students meet or surpass their SAT goals, and I scored a 1590 on the digital SAT. I don't know if you guys know this, but I was the very first person to ever come out with SAT predictions videos. So I bet you $1 million that you can't find someone that did a predictions video before my first one in September of 2022. Since then, all the YouTube influencers have been copying me, but I guess copycatting is the highest form of flattery. So I am coming back at you in this video with 10 problems I think are sure to show up on your August test. If you've been prepping all summer or you're trying to get some last minute cram in, you have come to the right place. But first, can we all agree that prepping for the SAT is like eating a burrito that is too big for your mouth? It's overwhelming, messy, and no matter how you approach it, you end up stressed out and questioning your life choices. Before we get started, big shout out to the sponsor of this video, the Preply app, which is the OG digital SAT prep app that's available in the App Store and in Google Play. We just did an amazing update for 2025, guys. We've redesigned the app and added in new questions that look and feel just like the questions that are showing up on your SAT test right now. So if you like the idea of doing a little bit of daily practice right from the palm of your hand, you can do it in study hall, on the bus, when you're waiting for a friend. I will link up here right now. Head to the App Store or Google Play and download Preply today to help push you over the finish line for August. All right, guys, grab your snacks, get comfy, and let's dive into my 10 predictions for the August test. And before we get started, drop a comment below. Let me know what you're trying to score on the August test and what you've been doing so far to try to get there. Heads up, I've linked all the problems to this set in the description below so you can work alongside me. All right, guys, my first prediction on the August SAT is there will be a question where they ask you about something being displayed as the coefficient or the base. This is a confusing question to students unless you truly understand what the SAT wants. They just word it so fancy. But if you see them talk about displaying something as a coefficient or the base, or sometimes they'll say the coefficient or the constant, all that means is that when you put in the value they give you, do you see the same number as the result that is already displayed in the question? So let me show you what I mean. It says for the exponential function f, the value of f of 1 is m, where m is the constant. Which of the following equivalent forms of the function f shows the value of m as the coefficient or the base? So when you see f of 1, basically that means x is 1, right? That's how we read function notation. So if we want to find a number that is displayed as the coefficient or the base, we're going to put in 1 for x into all these and see what we get. Now, what happens when I do this, I'm going to square 1.5 and then multiply it by 52, and I'm going to get a new number. That number is not something that's in this original problem, so that one's out. When I do 90 times 1.5 to the first, well, that's 90 times 1.5. I'm also going to get a new number, not something that was originally displayed in the problem. When I do C and I put in 1 for x, I have 152 times 1.5 to the 1 minus 1, which is to the 0 power, right? Now, anything to the 0 power equals 1. So I end up with 152 times 1, which is 152. 152 is displayed as a coefficient in the original problem. Since I can see it in the original equation, I'm going to pick C and move on. All right, problem number 2 is a trig problem. I definitely think a trig problem is going to show up on the test. My biggest advice is if they don't give you the picture, make sure you start by drawing it. So we have in right triangle PQR, where PQ is the hypotenuse. So let me go ahead and draw that in. I've got PQR. And be careful, guys, because I could see you making Q the right angle going down, counterclockwise. PQ is a hypotenuse, so make sure you label the sides correctly. We have the length of QR is 54. What is the length of PQ? Well, if we don't know that, I'm going to make that X. So I can see from my answer choices, the referent angle is Q. So always look to your answer choices to know what angle is the referent angle. So we're going from this angle right here. So that means we basically have adjacent and hypotenuse. So that's a cosine situation. So I'm going to say basically cosine of Q equals 52 over X. Okay? So from there, I'm going to solve for X because that's the length of PQ. So if I basically cross multiply, now I have X cosine of Q equals 52. Now I'm going to divide by the cosine of Q, and that's how I get X. So I want the answer to be 52 over the cosine of Q. Oh, I don't know why I did 52. Sorry, guys. You know what I mean. 54. Come on. Cut me some slack. I'm a human being. But obviously, I would have looked at the answer choices and then caught that mistake, which just happened just now. So we've got 54 over cosine Q, which is going to be C. So look for your referent angle, draw a picture, set up the equation. You're golden. All right, guys, if you're liking this video so far, listen, I come out with free content every single week to help you master the SAT. It doesn't cost you anything to just smash the subscribe button below and also hit the notification bell so you get alerted when I come out with a new video. All right, my third prediction is you're going to get one of these tough linear equations. I say that they're tough because the y-intercept isn't obvious until you work through it. It's really the setup that's tough, but once you know how to set it up, then it's smooth sailing. We have tickets sell for $47 each for the first 25 people. I don't know why it says that should say 4. And also these all should say A, B, C, and D. After the first 25 people, any remaining tickets sell for $65 each. What is the number, or what is the equation that models this, given n is the number of people and n is greater than or equal to 25? Okay, first things first, I notice a lot of students really focus on this. That's just kind of a disclaimer. You can ignore those things. But what we need to do is we need to figure out, you know, with a line, what's our slope and what's our y-intercept. Now, when they charge 47 for the first 25 people, that's going to be like a straight, you know, dollar amount because we are having more than 25 people show up. So no matter what, we're going to get this amount of money. So we're going to do 47 times 25. That'll give us the amount we get from the first 25. Now we're going to add on to that the next amount of people. They get charged $65 each. So I'm going to put 65 on the outside and I'm going to do n minus 25. That's the key because we already have the first 25 people counted for here. So from the total people, we have to take away the first 25. If you don't take away the first 25 people, what happens is it double counts. You charge them $47 up front, and then you charge them another $65. You don't want that. So then you just, you know, crunch some numbers and work through the question, and then you'll end up getting your answer, right? So I can already tell without having a calculator, it's going to be a negative y-intercept because I know 47 times 25 is going to be less, that's a positive number, than 65 times negative 25 because 65 is more than 47. So I can actually use some logical reasoning on this without going right to the calculator. There's only one negative y-intercept. I'm going to go with A. All right, guys, my fourth prediction deals with no solution systems. I think you're going to have one of those on your test. If it's not a no solution system, it's going to be an infinitely many solution system. So with no solution, and you have two lines, they're parallel. They're never going to touch because solutions are where they cross. With infinitely many, it's going to be the same exact line. They're going to overlap with each other. So in this case, since it's no solution, we've got a constant right here. We're going to have a slider for it. And we want to move it around until those lines are parallel. But the cool thing is they already gave us 4 values of h. So instead of moving the slider around and wasting a whole bunch of time, I'm going to be super strategic and type in each value for h until I get them to be parallel. So let me show you what I mean. Okay, as you guys can see, I have the two lines graphed, and now what I'm going to do is put in the different values for h. I think the first one was 2. That doesn't do it. Then we have 5, 10, and 15. Let's try 5. That doesn't do it. 10. Perfect. 10 is the answer. As you can see, they're perfectly parallel. All right, guys, if you're finding this video helpful so far, show me some love. Hit the like button below. Let's go to question 5. Okay, my fifth prediction is that you're going to have a question that requires you to employ your knowledge of exponent rules. Also, there's going to be multiple questions on this test that also require you to interpret function notation. So I took a great problem from our SAT math workbook, and it merges those two things. Let's go over this one now. We have f of x equals c to the x, and the function f of x, c is a constant, and f of 5 equals 16 times f of 3. What is the value of c? Okay, again, function notation. 5, since it's in the parentheses, it stands for the x value. So what I'm going to do is I'm going to put c to the 5th, and then I'm going to have it equal 16 times, now we're going to make x 3, so c to the 3rd. Well, we already know exponent rules because when you multiply like bases, like for instance, c to the 5th equals c squared times c cubed, because you add those two exponents, that means 16 equals c squared. So very easy enough. C's got to be 4 because the square root of 16 is 4, and then you're moving on. It's just a matter of understanding, okay, what does this function notation mean? If it's inside the parentheses, it's the x, plug it into the problem, and then go from there. All right, my sixth prediction deals with interpreting an exponential growth equation. These things are super popular on the SAT. This one might look a little fancy, but it's really not that bad. So let me just run you guys a few things you need to know. The number on the outside of the parentheses, that is your initial amount. The number that's the decimal part inside the parentheses is your percent growth. So it's a 24% growth. And then the exponent out here is the time. So, you know, x is in years. So it looks like this will iterate every 5 years, because when x is 5, meaning 5 years, then you divide by 5, you get 1 iteration. The exponent becomes 1. But this would be a module 2 problem, and not everything is going to meet the eye. So we have, for the given function f, the value of f of x increases by p% for every increase of x by 10. What is the value of p? Ooh, that's where the monkey wrench is thrown in, because they want to know the percentage increase when x increases by 10. Okay, so here's the key. Okay, when they talk about an increase in x, you need two values, okay? You need an initial amount, and then you're going to compare it to the new amount to see how much the percent increased by. If we made x 0, that's always the best way to start. So when x is 0, essentially you have something that's 0 power equals 1. You're going to get 36, okay? Because it's going to be 36 times 1. Now, when we make x 10, what happens is we have 36 times 1.24, 10 divided by 5. I'm putting 10 in for the x, and that ends up being a 2. So what I'm doing is I'm taking the 1.24 and I'm squaring it. So essentially, I'm going to multiply whatever number I get here by 36, and that's going to tell me how many times bigger it is than 36. So that's really going to be my answer. So I have 1.5376. So that means it's 53.76% bigger than the original amount, because remember, the growth happens here with the decimal, not with the 1. The 1 just preserves the original value of 36. So there you have it. Now, you can fit all 5 of those digits. If this is a grid-in answer where you're typing in your response, you have 5 spaces. So you can fit 5, 3, point, the decimal's a space, 7, 6, exactly 5. If you end up having a longer decimal than 5 spaces, what you're going to want to do is round the last digit. But please do not round prematurely. Fill in all the spaces unless they say round to the nearest 10th or something. Otherwise, they will mark it wrong and you will lose the point after all that hard work. All right, my 7th prediction is that you're going to have a probability with a given statement. Probability is an interesting type of question because if you have a probability question, it's only one per test and it may not show up on every test. So this is a little risky that I'm predicting that you will have this question, but I just have a feeling in my gut that it's going to be on here. So make sure you come back to this video and comment below and let me know if you saw a probability with given statement question. So here's the thing. If they say, and like, let's just go right to the question. What is the probability that the participant will be from group A, given that the participant is younger than 20? When you have that statement, given that the participant is younger than 20, that's what you really need to pay attention to. That means they can't be 20 or older. So this whole row right here of the 20 plus years old, we have to get rid of. Now the total isn't out of 105 anymore, it's out of 70 because 35 plus 35 is 70. These totals also change. We end up with 24, 18, and 28. And that's what you need to keep in mind because I see lots of students remove a whole group, but then they don't change the total and then they get the whole thing wrong. So now we're trying to figure out what's the probability that the participant will be from group A. Well, as you can see now, group A is 24. So we're going to put that on top out of 70. Now, these are both even numbers, so you're going to want to reduce that down. So you can divide by 2, divide by 2. You end up with 12 over 35. And what you could also do is quickly type it into Desmos, get it in decimal form, fill it in decimal form if that makes you feel safer. You could even type in the fraction to see if Desmos reduces it more. But make sure when you enter a fraction in as an answer, it's always in simplest form. If you don't put it in simplest form, you will also not get the point. And that is so tragic when you've done so much work. All right, let's talk about equivalent expressions. So if they talk about equivalent expressions in the problem, which I think one of these is going to be on your test, they might also word it as can be rewritten as. So if you see either one of those expressions, that's a sign that you should just put it right into Desmos. Your goal is to get the graphs to overlap. So they're basically saying this function f of x equals 2.15 to x over 4 is basically equivalent to this one. Now, what's interesting is we're going to have one constant here. P is a constant, so there will be a slider. But what's cool is, again, they give you 4 values of P. So I don't need to spend endless amounts of time moving the slider around till they match. I'm going to be strategic, I'm going to be efficient, and I'm just going to type in those values for P. So let's go ahead and put it in Desmos. Okay, as you can see, I have the 2 graphs in Desmos, and now I'm going to type in my values for P. So we have 18, 21, 47, and 98. 18, there's a little bit of separation. 21, wow, that looks really close. Not perfect, but pretty close. 47 is way far. I'm sure 98 is going to be worse. Yeah. So 21 is the closest. I'm going to check the wording to make sure, you know, sometimes they'll say what is the closest to what best approximates. This one didn't say that, but typically if it's a little off, that's what it will say. But I'm going to be confident going with 21 because that definitely made the graphs look super similar to each other. All right, my 9th prediction is that you are going to have at least one opportunity on the test to do a regression in Desmos. Now, to run a regression in Desmos, you just need 2 things. You need to have at least 2 points, sometimes 3, depending on the type of graph, and the equation. And as you can see here, we've got that because they gave us at least 2 points. They gave us 3 points. and they gave us the equation of the function. So notice, here's one thing. We have autoregressions. I know you guys know about this, or a lot of you do. You cannot run an autoregression on this because an autoregression does not have this specific equation in it where it's divided by x plus 5. You're going to have to manually type this one in. But fear not, I'll show you how to do it. Let's start by entering our values into the table. So in Desmos, I just like to do this as quickly as possible. I'll type in table and it will come up. I find it to be a little bit more efficient than hitting the plus sign. Okay, on the next line, I'm going to type in my regression. Now, there's a few key rules for doing a regression. Don't use function notation, so f of x's, h of x's aren't going to work. You need to use y1s and x1s. Why is that? Well, because then it's going to pull from the table. As you can see, the column headings are x1 and y1. So it basically tells Desmos where to pull the values from. So from the equation, since it started with an h of x, which is a fancy way of saying y, I'm just going to type in y1. Rule number 2, you cannot use an equal sign, you have to use a tilde. The tilde is the button right next to the number 1, so if you hit shift and then that button, you will get the tilde. This is just basically telling Desmos you are running this regression program. Think of it kind of like code. It's like its own language to tell it what to do. Now, the next thing we need to keep in mind is on this side of the equation, we also have function notation. We can't put that on top. It's going to confuse Desmos. They did say f is a linear function. I know my equation of a line is y equals mx plus b. Now, you have to keep in mind we already have the y out here, so to put another y here would be redundant. So we're just going to put in the mx plus b part on top. Because I want it on top with something on the bottom, I'm going to put it in parentheses. And I also have to keep in mind, I can't just put an X. I will have an error symbol. I need to tell it to pull from the X1 column. So I'm going to put mx1 plus b. Okay, now I'm going to divide it by what the rest of the problem said to divide it by, which is x plus 5. Again, make sure you type in x1 plus 5. And there you have it. So the problem's asking for the y-intercept of the line, which is the f of x part on top. The y-intercept of the line is the b. So when you look at the regression parameters, b equals negative 300. So that's going to be your answer. What you don't want to do is you don't want to go to the graph and go, oh, my y-intercept is negative 60. That is not the answer to this question because they want the y-intercept of f of x. That is the graph of h of x. So just be very careful. All right, guys, my last prediction, we're almost done, is a conversion problem. I think you're going to have a conversion problem on your test. So a lot of these conversion problems are super sneaky tricky because they require you to convert from one-dimensional to two-dimensional or three-dimensional units. So as you can see, this question says a container has a volume. Okay, so volume is three-dimensional, right? Length, width, height. And you can even see the language. This is three-dimensional language, cubic meters. Well, if we're talking about cubic meters, I already don't like this conversion because that's just in meters. It's one-dimensional. So what I need to do is I have to cube both sides of this to get it to be in cubic meters and cubic centimeters so that I can use it in the problem. All right, so we're going to have 1, 0, 0, 0, 0, 0, 0. So we have 1 million cubic centimeters equals 1 cubic meter. Okay. Now, what's cool is after that, they want it in quarts. So we have cubic centimeters to quarts. We don't need to change that up at all. We already will have it in cubic centimeters and we just need quarts. So there's no need to square that or do anything to that one. Now it's just a matter of setting it up. So we have 1.2 cubic meters. And what I'm going to do first is convert that to cubic centimeters. So I want to multiply. And I'm going to put my meters cubed on the bottom, my cubic meters, so that it will cancel with cubic meters. I don't want cubic meters anymore. I want cubic centimeters. And then what I'm going to do is I'm going to multiply one more time, and I'm going to multiply by, I want to get it in quarts, right? So I'm going to put the cubic centimeters number on the bottom. So that cubic centimeters can cancel with cubic centimeters. I'm going to put the quart on top. Now all you need to do is multiply through. You multiply straight across. So we're going to do 1.2 times 1 million. That's going to be 1,200,000. And that's quarts because times 1, that won't do anything. But as you can see, we only have quarts on top. And then we have to divide that by 946.35. Let's do that right now. And I get 1268, which is C. And there you guys have it, my top 10 predictions for the August SAT. I hope that this helps you feel more confident going into the test, and just make sure you work smarter, not harder. Big thanks to the Preply app for sponsoring this video. Don't forget to download it and get those extra reps in. I will link up here again. It's like having a tutor in your pocket minus the awkward small talk. Not that me and my team were awkward or anything, but you get the idea. If you found this video helpful, make sure to give me a thumbs up and share it with your friends who are scrambling last minute. Also, comment below with a crystal ball emoji for predictions, because then I'll know you made it all the way to the end of this video. Thank you for being a ride or die. All right, guys, good luck studying. Until next time, happy prepping.